So section 5.3 is complex fractions. What this is fractions in which either the numerator or the denominator contain fractions of their own. So in kind of short and sloppy speak, it's fractions of fractions. Okay. So a complex fraction, usually we want to simplify to a regular fraction. So a complex fraction is a fraction in which one or more terms, I just wrote out what I just told you, in the numerator or denominator is a fraction. The way you solve these is by multiplying the main numerator and the main denominator by the LCD of the smaller fractions. So by main numerator, I mean the big numerator. Same with denominator, by the LCD. So of course I'll show you an example. This is a complex fraction. So I've got in the numerator, the main numerator is 2 over x minus 3 over x plus 1. The main denominator is 1 over x plus 4 over the quantity x plus 1. So it's fractions of fractions. So So we want to multiply the main numerator and the main denominator by the LCD of the smaller fractions. This is just easier than subtracting the 2 in the numerator and adding the 2 in the denominator and then flipping the denominator and multiplying. This is just easier, okay? So I have to find the LCD of the smaller fractions. Well, there's only 2 factors involved here. One is an x and the other is an x plus 1. So I have to make all these x times x plus 1 in the denominators, the little denominators. Okay, so maybe you write down what the LCD is, maybe, if that makes it easier for you. Now, notice I'm multiplying the main numerator, not the numerator, not the top and bottom of each of the little fractions. So I'm multiplying the main numerator by x times x plus 1, and that means I multiply each term of the main numerator by that, and that means that you multiply the numerators of each term by that. And then I do the same thing on the bottom. And then these little fractions will all cancel out, right? You'll cancel, where am I? These 2 will cancel. This will cancel with this. These 2 will cancel. And this will cancel with this. We call this clearing the fractions. We're clearing the little fractions. So those cancel, those cancel, those cancel, and those cancel. So I write out what's left. And I just multiplied the 2 times x, 2 times 1 to get 2x plus 2. Because I know I need to combine it with this other thing here. And this is minus, be careful, minus is minus 3x. Tink. Then I have to combine these 2. And on the denominator, x plus 1, right? And then all that's left here is 4x plus 4x. So now I need to combine the x terms on numerator and denominator. So we get 2 minus x and 5x plus 1. And those are just, so the numerator has 1 factor, the denominator has 1 factor, and they're not the same, so they don't reduce. Okay? Check your answers by trying, on these I would check my answers by trying a few numbers in the solution and in the original to see if you get the same thing. So you have to put in something that's allowed, so you can't like put in the original, you can't put in x is 0 or x is minus 1, right? So I would start here. Let's say we put in x is 1. That makes this one easy. 2 minus 3 halves. You can do this on your calculator, right? 2 minus 3 halves over 1 plus 4 halves. 1 plus 2. The bottom is just 3 if I use x equals 1. and then put x equals 1 in here and see if you get the same number. Now that doesn't guarantee that you did it right, but it's a fairly decent chance. If I do a second number, say 2 for x, then and put this in your calculator. Make sure you put parentheses around the numerator when you put it in the calculator, and then divide, and then put parentheses around the denominator so it divides it right. I could pick like 2, put it in here, and then try 2 in here and see if I get the same number, compare the results. If you do with 2 different numbers, then probably it's right. A lot of times we try to use the number 0 for this, but because that's an easy number to use. But that doesn't work so hot here because you can't divide this one by 0. You get nonsense. Okay? So this one checked out. So I'm writing out for you what I do. So, and I actually write this on my paper. I write x equals 1, colon, underline it. I'm testing whether this works for x equals 1. And then I wrote it out. And I usually, if I'm going to put it in the calculator, I usually write it out first, then put it in the calculator. It's a lot easier to put it in the calculator correctly if you have it written on your paper, right? I just worked it out. I came up with this, 1/6. That was putting 1 in to the original equation here. Now I want to put 1 in here and see what happens. I should get 1/6. 2 minus 1 over 5 plus 1 is 1 over 6. Bingo. So probably I did this right. I could try another number to make myself a little bit more confident. If 2 of the numbers work, there's a pretty good chance it's right. It's not proof that it's right, but it's a pretty good chance. If you just go through and check the steps, you know, you do that. If they come out not equal, then you have to go through and check the steps and see where you went wrong, which will either be a canceling mistake or a problem with a negative usually, or you factored something wrong. Remember, when you factor something, you should always check immediately whether you factored it right. On this one, I didn't have to do any factoring, so that couldn't be it. Okay, next example, next video, I just have more examples, I believe.